Good day, I'm Osbonyako and I'm doing this video with Caleb Eche, Group 22. So in this video, we're talking about vacuum crystallization. We're talking about the construction, the application, advantages, working and the disadvantages of vacuum crystallization. So let's get to it. Okay, so let's get on with the introduction. Vacuum crystallization is a process of forming crystals from a solution by reducing the pressure within the system, which lowers the boiling point of the solvent. A vacuum crystallizer operates on the principle known as the adiabatic evaporative cooling, thus lowering the pressure within the system to reduce the boiling point of the solvent. This allows for the controlled formation of crystals without the need of high temperature, making it energy efficient and effective method for processing heat sensitive materials. In this presentation, we will be explaining how vacuum crystallizer works, the advantages and disadvantages, and their application in industries such as the pharmaceutical, petrochemical, food, and production. Let's begin by understanding the basic principles behind this fascinating technology.
Now, coming to the construction of a vacuum crystallizer. A continuous vacuum crystallizer consists of a tall vertical cylindrical vessel with a conical bottom, just as displayed on the screen, a circulating pump of low head, and a vertical tubular heater on the shell side of which steam is condensing. A low pressure is maintained in the vertical cylindrical vessel by a condenser, usually with the help of a steam jet injector. A, tang- a tangential inlet is provided on the cylindrical vessel for introducing a hot solution into it, and a vapor outlet is provided on the top. A discharge connection for the mother liquid and crystal is provided on a downpipe just above the feed connection. And now let's talk about the working of a vacuum crystallizer. Before that, I want you to know that there are other types of vacuum crystallizer, some of which include the oscillate vacuum crystallizer, the continuous vacuum crystallizer, and the batch vacuum crystallizer. But here we'll be talking about the working of the continuous vacuum crystallizer. Now, there are key things to note down. That's the energy efficiency. Low temperatures are maintained due to vacuum conditions, and the controlled crystallization, where the temperature, pressure, and flow rate are precisely controlled for optimal crystal growth, and high purity, which says impurity often remains in the mother layer, producing high purity crystals. Now, a high vacuum is created using a pump. The vacuum so created must correspond to the boiling point of the solution, but lower than the feed temperature. A hot saturated solution is fed into the crystallizer at a convenient point. Solution undergoes flushing, which results in evaporation of the solvent. The process is allowed adiabatically so that the crystallizer body is cooled. The resultant cooling causes supersaturation and crystallization. The evaporation of the solvent enhances the yield. The propellex mix the content thoroughly and prevents the content from reaching the discharge pipe without flashing. With the help of a pump, the product is collected and subjected to filtration or centrifugation to obtain the crystals. The filtrate returns to the feed. This is another type of a vacuum crystallizer. Applications of vacuum crystallizers. Vacuum crystallizers are widely used in various industries for separating and purifying substances, especially when dealing with heat-sensitive material or when high purity is essential. In the pharmaceutical industry, Its purpose is for purification of active pharmaceutical ingredients. Example, the crystallization of antibiotics or vitamins. And in the chemical industry, its purpose is for the production of high purity chemicals and intermediates. Example is the manufacture of inorganic salts and organic acids. In the food processing industry, its purpose is for the refinement and concentration of products. Example, sugar refinery, salt production, and crystallization of citric acid or other food substances. In the mining sector too, its purpose is for the recovery of valuable minerals from solutions. And we have other applications as well, like in the petrochemical industry, where its purpose is for the separation and purification of hydrocarbons. Lastly, we'll talk about its advantages and disadvantages. And its advantages are that the controlled environment minimizes impurities and enables precise crystal formation. This ensures the product quality for pharmaceuticals, food, and fine chemicals. Another advantage to talk about is its flexible operating. The vacuum crystallizer is very simple without many moving parts, can be designed for batch or continuous process based on its equipment. Its disadvantages are that setting up a vacuum crystallization can be very costly and expensive, and its maintenance too is very costly. And the last but not the least is that it works slow. Thus, it can be slow compared to other crystallization. Thank you.